to help you out with your outdoor vegetation lab. So you'll want to download this file right here first, the outdoor vegetation lab data, and you'll use this to answer all the questions. So this is all data that I collected on Sunday at my house around noon when it was sunny and fairly hot for this time of year. And what I did was I have some information on air temperature and humidity in both the sun and the shade. And then I used an infrared thermometer, which is like the temperature gun, to look at the temperature of different surfaces. And so you can see I have 3 different surfaces: concrete, grass, and asphalt. I looked on surfaces that were in the sun and in the shade, on different sides of the building and different colors. And then there are 4 temperatures for each one, and each measurement was taken at least 2 feet apart. So some of the questions will ask you what surface was the hottest, which surface was the coolest. And you can use some of these characteristics. You can also think about the angle of the sun. So at noon, up here, it says the approximate direction of the sun. So you can think about how long they may have been in the sun during the day to help you answer that question too. And you can take the mean to help you figure out which one is the hottest and which one is the coolest. But one of the questions, the one that's worth the most points, will ask you to come up with a research question and do some statistics. Now, before you try to do this, please do the statistics tutorial. So what you need to do is come up with a research question, and you want to only vary one thing. So if you want to know the difference between, if you want to know whether grass is hotter in the sun or the shade, you want to control for this building side. The color obviously will be the same. But so you would want to compare grass in the sun and grass in the shade, both on the south side of the building. You can do the same thing for the north side of the building. You could also compare grass and concrete in the sun on the south side of the building. So just make sure whichever thing your question is about, you control for the other things, meaning that you keep them the same, because otherwise you won't know which variable is important for the difference. So then in the assignment will be a link to this website. It's very handy. It will help you do statistics without having to do anything very complicated. So this will be a t-test, and leave the choose a test part alone. It's an unpaired t-test. That part is correct. You're going to label your groups. So I'm going to give you a different example that I'm just going to make up here real quick. So let's say we're going to look at the length of male and female lizards of the same species. And I'm just going to put in some numbers. Okay, so these are all the length measurements I took for male lizards, and these are all the lengths I took for female lizards, and then all you do is hit calculate now. And then these are your results. So the p-value, you can see, is the first thing it tells you. So 0.02, I want you to go back and think about whether that's statistically significant, but it'll actually tell you right here. The next thing gives you the confidence interval, which you're not going to really need to worry about for this. In your sentence, you'll need with the statistics included, you'll need the t-value. df is the degrees of freedom, and then you'll need the p-value, and then you'll need to be able to tell which one is bigger. So in this case, you can see the mean for females is much bigger, and it says it's statistically significant. The p-value is 0.02. So a good sentence for this would be that female lizards are longer than male lizards. And then in parentheses, put t subscript 6 equals 3.06, comma, p equals 0.02. And that's all you need to write. So hopefully this will be straightforward, but shoot me an email if you're having problems. Thanks. Bye.